Okay, I guess it's time to start. Sure, but so this is Tcpinc. We're going to start the meeting. The blue sheets are circulating. Please sign them. We need minute takers. Excellent. Thank you very much. Okay. You can find the not well on the screen. And this is our agenda for today. I mean, if there are comments, you want to change something, add. Okay. You want to?
So we currently have 2 drafts that are we are targeting to. This meeting is trying to select one of those, and we are going to have a presentation of both of them, and then we're going to have a discussion. Or actually, we have a short presentation also about the framing protocol after that. But I think actually most of it seems to be already covered in most of the drafts. So, but I think there's we have a strong representation of ADs in the background, and they will actually perhaps have some comments. I don't know if you have now any comments or later, hopefully listening to the discussion, but we will see. So I don't have that much more to talk about the, for the intro. So
the ADs just listen carefully for the beginning at least, and then let's see.
All right. So I think let's go to the first presentation then.
All right, so I'm Andrea. I'm going to talk to you about TCP-Crypt. All right, let's go. So I'm going to, first of all, just give you a brief review on TCP-Crypt, so it's mostly material you're already familiar with. Then I'll talk about, the issues that have been, is this thing even working, or? Okay. I'll give you an overview of the issues that were raised on the mailing list and by you guys and how we plan to address them. And then I'm going to spend a little bit of time on what we think are kind of the cool design features in TCP/Crypt that we'd like to see moving forward, regardless of what draft is selected. All right, so this is the handshake protocol. It's a four-way handshake, mostly in TCP options. The init1 and init2 messages are sent in the payload because they're big, and I'll talk a little bit more about them later. And then what we do is we encrypt and MAC payload data, and we also MAC parts of the TCP header. And we stick that MAC as a TCP option. So that's kind of like our current design and what we've started with. So, once you establish a TCP/Crypt connection, what you get back is a session ID. So you could call a get sock opt on the socket if you're kind of like TCP/Crypt aware, and you get back a hash. And in this case, the number is like ABCD. And if you compare these two session IDs, it means that there was no man-in-the-middle attack, right? So by default, you get protection against passive eavesdropping, which is what we care about in this particular working group. But kind of, now that we've kind of done the hard work of establishing a key, why not let application authenticate on top of that if they wish to do that? And really, the authentication mechanism is completely agnostic, right? You could sign that session ID using a certificate. You can maybe share a cookie with someone and use that to like send over an HMAC of your session ID or whatever. It's just left up to the authentication. This is kind of the split of encryption that is done by TCP/Crypt and then authentication that is left to the application. So next slide. One thing I haven't talked about much in the past to this group was about the application support bit in TCP/Crypt that we actually feel is an important design feature, and we'd like to see that present in any draft that moves forward. So, now that we've got the session ID, the problem is, how do I authenticate the session ID, right? So, one option is to change the underlying protocol of the application, right? So maybe use, something similar to, send a start authentication command or something like that. But we're kind of back to square one, right? If we want to just be backwards compatible or use existing protocols without changing them or existing applications, we need an out-of-band way of signaling whether the other end supports, whether the other end's application supports TCP/Crypt, so I could send over the authentication data. So kind of like in a similar way that today we're signaling, hey, do you speak TCP/Crypt? Yes, let's encrypt. We need one more bit to say, you know what, does your application support TCP/Crypt? Oh yes, let's authenticate, right? So kind of like in the long term, what we would expect is that today, we just get no protection whatsoever if the other end doesn't support something like TCP/Crypt. Once TCP/Crypt is deployed or a similar solution is deployed in the kernel, we get passive eavesdropping protection. And then if apps choose to use this framework, they can even get protection against active eavesdropping. Next. So the status of TCP/Crypt today, thanks to actually some of the people in this room, we got official Debian and Ubuntu packages and an official Fedora package. And then we have our kind of existing implementations for macOS, Linux, and Windows. So, this is something that you could pretty much download today and start using. It's ready to go. Obviously, it's based on the current draft that doesn't address any of the issues that were brought up recently on the mailing list. Nice. So that's where we are today. So what are the issues that have been brought up, and what are we going to do about them? So, the kind of the main issue is the way we're dealing with the TCP header, right? We're macking the TCP header, and we're also placing the MAC option in the TCP header. And there's kind of this sentiment that that's just going to break middle boxes. So kind of to the first point, should we MAC the TCP header or not? It seems like, there's been a decision already, just don't MAC the TCP header. And so, that's a pretty easy fix for us. We're just going to get rid of all mention of macking the header from the draft. We're just going to go ahead and do that.
I have a Brian Trammell. I'm not sure which hat I'm wearing here, but they're all angry. I have a question about the sentiment that this won't get through middle boxes. So you had the MAC, you had this option on the earlier revision of this protocol, correct? So macking the header, that's what TCPcrypt did, or does right
yeah,
now,
so
right? The
TCP
implemented code does that now, yeah?
Right, and it maps the
Do you-
header, and we tried to be also middle box friendly, so we don't like
Yeah,
mac the
yep.
port numbers and
Yeah.
stuff like that.
Do you have any sort of data on the experimentation that you've done about how often you actually ran into problems with this?
We don't have conclusive data.
Okay. Do you have anecdata?
We've got some data.
Okay.
Like I was just like looking at the logs on the
Okay.
coming here, and we have like. Yeah, I don't really have exact numbers to share.
Okay.
But,
so I think this discussion should be much more informed by data than it has been.
And I look, I totally agree with you. And part of it is like on my log, I had like 1,000 samples that I was.
Yeah.
looking
Okay.
at,
so that's not data.
really. It's not real. It's not
Right,
really
yeah,
data
yeah.
that's useful to
Yeah.
anyone. So that's part of why we were trying to standardize this thing, so we could get it out there and learn about it. But it is a bit of a chicken and egg problem, right?
Yes, it is.
I wish
so
I was Google or something. So
there might be some people in this room who could help you with that.
right, yeah. So and I think that's been an ongoing discussion. Like there should be like measurement work done before we just kind of say, look, header protection is bad, because in a way, if we could get away with header protection, that'd be great, right? It's just like more security, right? The question is, does it work? And it feels like we don't really have a clear answer to that. Okay, so anyway, it seems to have, there's been an executive decision of not macking the header, so let's just not mac the header for now. It seems like, there are other battles that we have to worry about. The next thing was to use EDO, right? And, Tcpcrypt was designed in 2010 when stuff like EDO just wasn't around. So, sure, like for the Mac option, let's use EDO. For the init1 and init2 messages, I don't think EDO is a good fit, because we're going to have to, first of all, retransmit those segments. They're just tied to the stream, right? We're exchanging key material. Key material could span multiple segments. Like, let's say if in the future we need super long keys or whatever, and we don't want to be limited to 1,500 bytes or whatever, the usable TCP space is. So I guess the bottom line for EDO is absolutely for the Mac option, not for the init1 and init2 messages for the handshake. And in fact, even the TLS option does not use EDO for that same reason. And so I think the big open question left is, what do we do about the Mac? Where do we store it? Do we store it in the header, which is what Tcpcrypt currently does, or do we try to put it in line with the data and have some sort of framing protocol, something more similar to TLS? I think that's kind of the big open question we have. And the answer, our response to that is it's going to depend on what we decide today. And Tcpcrypt could really go either way, but there's pluses and minuses to what we decide. So, Tcpcrypt already uses a type length value encoding for the init1 and init2 messages. In fact, if you go to, let's just go to the next slide real quick. Right now we've got a magic number for an init1, which is effectively a type. We've got a length and then all the key material for the server, for the client. And then the init2 message, again, it's got a type, a length, and a bunch of key material for the, for the server. So TLV is already being used for the handshake. Now the question is what it would look like if we use TLV afterwards. So next slide. So what we would do is we would have a length, a type, which would be probably like user data or rekey or whatever it is, and then the actual data, which is encrypted in MAC, followed by a MAC, right? So whatever we're doing today in options, we could just move it down to the byte stream, right? There's no really main change here. It's more of a design choice. And so really, the question comes down to what are the trade-offs? So the good news about putting the MAC in a TCP option is that it's kind of simple, right? So now we could just implement this as an easy packet rewriter. We're not messing with TCP's data stream. We're not buffering things, right? We're not having to receive packets potentially out of order, buffer them. We still haven't checked the MAC. We have to, receive a whole record before we could even MAC the packet and decrypt, MAC the stream and decrypt it. So that's kind of one advantage of just putting the MAC option in the header. We could just process packets independently. It's also easy to, if we receive a bad packet because the attacker flipped bits or something, we could detect the problem on that packet and just throw away that packet, right? We don't have to like necessarily tear down the entire connection or something like that. So that's a nice property to have. And there are no changes to the TCP kind of data semantics. The flow control is the same. The semantics of the window size are the same because all usable data is user data, right? We're not adding metadata. And so socket buffers are kind of the same. So we don't mess with any of that. Arguably it makes the TCP trend, the TCP state machine and kind of the steady state kind of simpler to think about. Now, what are the advantages of going TLV? And that's what's been really proposed mostly by the working group. The main advantage is that it's more robust to middle boxes, right? So if now you split packets, or if you strip options, or you coalesce packets, you don't have an issue anymore, right? Because you don't really care about option space at this point. Everything is inside your data. So that's kind of the big selling point. And it kind of just will work out of the box with a lot of middle boxes or TCP segment offloading and stuff like that. It will just work. We don't have to like re-engineer any of these mechanisms. So that's kind of, there's some simplicity and compatibility that is nice with, well, actually not so much simplicity, but there's some compatibility which is nice to doing this all at the application layer. Next slide. So I think when I kind of like just step back from TCP crypt, I kind of view it as a kind of positive experience. I think TCP crypt was all about design choices and kind of like goals and like try to hit the sweet spot. And I think the good news is that a lot of these design choices, in a way, have been adopted by this working group, either directly or independently or whatever. Like, if we just like step back 2 years ago, the question was, why do this at all? Like, the question was, hey, let's just use IPsec or TLS everywhere. There's like no need for layer 4 encryption. And I think, we kind of got over that and saw that there is value in complementing something like TLS. Similarly, another key design feature in TCP crypt was the signaling of out of band for support, right? We've got the SYN packet. Let's try to like, signal whether the other end supports it so we could incrementally deploy encryption and we could gracefully fall back to clear text. And that's kind of like, the main trick in opportunistic encryption that we have. And that's been, I think that's another feature that has been adopted. This whole notion of separating authentication and encryption and having the session ID concept to be able to link the two, to give the application a chance to to authenticate also, in a way, I think has been embraced, just like with channel binding and TLS and things like that. So I think, I kind of look positively at it that, a lot of things, I'm kind of like seeing a lot of things I like in many of the the drafts that have been proposed. So next slide. So there are some other things, though, that we believe that are still kind of like interesting design features in TCP crypt that we would personally not like to leave on the table. These are kind of the things that still haven't quite been adopted, but we think they're important. I think the application supports bits that I talked about briefly in the beginning are really important, because now we're kind of like fighting this battle of, hey, does the other end support encryption or not? And we're going to win it. Then there's this next hurdle that we're going to run into is like, okay, now that everything is encrypted, it would have been so cool to see if the other end, was aware of the encryption and be able to support authentication. And it would be kind of disappointing to have to solve the same problem again, right? So being able to signal application support, I think, is really important here, right? It's not really 1 bit that we need. It's at a minimum 2 bits that we need, right, for a long-term vision. I don't think we should give up on latency, right? So if we already have the 3-way handshake there. Let's just make the most out of it, right? Let's signal support in the SYN. Let's try starting negotiating in the SYNAC, right? And possibly even be compatible with some of the other, efforts that are being done with like fast open. Let's try to, optimize if possible. If we're not giving away any security and we're not adding too much complexity, let's try to live with the high performance if we can. It'd be also nice if the result is kind of simple, right? So it's something that we can not only implement in a simple way, and possibly even like, do it, correct by construction given a formal definition of it or something like that. So kind of like a small and tangible and simple protocol, but also something you could kind of reason about, not something with potentially like a million knobs that for this particular instance of the problem, the pervasive monitoring problem, like a lot of these knobs are just not going to be used, but they're still there, right? So kind of have like a lean protocol, I think is something that really appeals to me, right? And could also, and also, adding to the diversity of the ecosystem was one of the other points that has been mentioned before in this working group. So I think like really these are some of the key aspects that we'd like to see survive in whatever we decide to do. So that's pretty much all I have. Thank you.
All right, any comments or questions about the questions? We will have another presentation about the TLS stuff, so if you have not comparing, but if you have any clarification questions now. No, I think then we move to the TLS.
So I think it's now traditional to start with some review and then, argue a bit. Next slide. Okay, so, I mean, this is a pretty obvious idea. TLS over TCP is everywhere. It's probably the most widely deployed security protocol, and it's been really heavily analyzed. There's been a lot of work on this. I think we understand the properties reasonably well. It better be true because we're depending on it constantly. So enormous amount of effort is going into it over the past, 8 years. One of the main problems with TLS has always been how hard it is to coordinate, and Andre just raised that point earlier, which is to say that basically either you have to have a in-application protocol handshake that says, I would do TLS, great, let's do TLS, or you have to have one side has to know the other side does it. And if you just try to start a TLS handshake with somebody who doesn't know TLS, well, he chokes on you for almost every application log protocol. So it'd be nice to have some way to solve that problem. Next slide. So we have this array of existing techniques, none of which lend themselves well to any kind of opportunistic deployment because they basically require either crappy performance or manual configuration or some other stuff, right? So I think the idea about having a signal in the TCP metadata as an out-of-band signal to the application is a great idea. Next slide. And so trying to turn that around, what I ask is, what's the minimum necessary thing to do to let you use TLS with TCP opportunistically without having to screw the endpoint applications? Next slide. And so the minimum thing is 1 bit, which is to say a bit here that says I would do TLS, and a bit here which says great, let's do it. Next slide. So, and obviously the other side says doesn't respond at all because he's just a naive person. Then you don't do TLS, mission accomplished. So if what your target is to have in-application security, this is probably the minimum set of things you could possibly do. Next slide. And as I probably should mention, one thing I want to mention is that this doesn't require making a commitment to where the implementation is, either the application or the kernel, because from the wire perspective, having the TLS looks identical. And so either you do this in the applications, which is nice, or for many cases, or you do it in the kernel, and applications just either turn it on or turn it off, or ignore it depending on configuration. So the signal that needs to be had here, as I said, very simple. In every case with simultaneous open, it's merely willingness to engage in this application layer handshake. And we had some bunch of discussion the last time about simultaneous open, and what I took home from the discussion was, let's not even worry about it. If there is need to worry about it, I have a backup slide for how to deal with this, but it's not complicated. Next slide. So this is the option we're talking about. Next slide. There's a bunch of discussion about if we're not going to protect the headers, as was discussed at the last time on the list, it still might be nice to have a secure end of connection notification. Luckily, TLS has something like this. There's this close notify alert. One minor problem here is that the half closed state isn't supported. So when you receive a close notify, you're supposed to respond during close notify and terminate the connection immediately. my experience with TCP has been, by the way, that half close is not very useful. I think most people probably find it to be the case. But certainly that would not be a problem to change the 3 lines in TLS which require you to respond to plus notify. Wouldn't cause anybody heartburn. Next slide. I don't know if you're in SAG, you probably heard Adam Lange's talk about Quick and how important, and if you're in TLS earlier today, you heard about how important setup latency is now. The naive design here has sort of mass setup latency. So the naive design here, and I'm assuming TLS 1.3, rather than 1.2, and TLS 1.3 is like 1/2 round trip faster, is these initial messages only have these initial bits, so not carrying any additional data. And so then basically you're doing a traditional TLS handshake exactly in the connection. So you're not getting any kind of overlap between the TCP handshake and the TLS. So in that case, basically the server is able to start transmitting data as soon as he receives data from the client. So from the server's perspective, basically it's a one-round trip protocol, and the same is true from the client once you get past TCP. Part of why you can get away with doing this, by the way, is the server doesn't care about authenticating the client, so the server can transmit even before the client is sent any kind of sniffing information, which is not always true in regular TLS. So basically, the server can send on his first flight, and the client can send on receiving the server's first flight. As I said, meh. It'd be nice to be faster. If we want to be faster, there are basically 2 things we can do. One thing we can do is we can turn around the handshake. And say basically that the TCP server acts as a TLS client. In that case, obviously, if you do that, then the server can piggyback his client hello on this SYNAC, and so you shave off a 1/2 round trip. That's really not very attractive. It'd be nice to have that 1/2 round trip back, but one of the attractive features of this design is that it looks like regular TLS on the wire, and so if you have inspection devices that are sad about things not being TLS, they don't get sad. So if we flip that around, the inspection boxes basically look at the TCP handshake to determine who should be talking first, and they're going to get sad again. So I think that's not an attractive feature. Next slide. If we're really to do EDO or any kind of data instant or TFO, we can do quite a bit better because we can piggyback the client's first message directly on that first message, assuming we're allowed to shove it there. And at this point now, basically we're down to an immediate round trip protocol where the server can send right away. There's obviously no way for the client to send right away. Unless you're in an environment where they've had some pre-existing negotiation, you have a pre-established key, like in Quick or TLS 0RTT. So I'm assuming that we're not doing like any kind of weirdo 0RTT tricks. But I will note that if you were to be in the setting, if you were to do TLS 1.3 to 0RTT, then of course you'd be able to transmit the client be able to transmit his first flight. So my basics, so the thing to notice here, and this is probably worth noticing for both TCP and for this document, is look how much edge we're getting by being able to use those first 2 messages. So it seems like an absolute critical invariant to make sure we can use EDO or TFO or whatever it is we want in this data. And as far as I know, that's not a problem for either of these protocols. But I just if we remember nothing else from today, it's that this is a critical part of making this not suck. Bob.
Just there's a bit of a vagueness here.
Oh, of course.
You keep talking about EDO, but EDO isn't on the SYN. It can't be done on the SYNAC either. So that's the,
I have to admit I haven't been tracking that part of the discussion clearly. My understanding was that there were designs for doing
there are, yeah.
initial data, but maybe it's not EDO.
Correct, and they've all got some problems.
Right, of course.
Yeah, okay.
So it would be great to have those work. So dear TCP guys, make them
including
work.
my own.
Yes, please fix that magic, and then it'll be awesome.
Stuart Cheshire. I may be missing something here. If we're doing this opportunistically, that implies that the application layer is a plain text application.
Yes.
And at the point that you send that initial SYN with data, with the bit set that said I'd like TLS if possible,
yeah.
If the other end doesn't do TLS, the client now receives a bunch of TLS hello message that it doesn't understand because it was telnet.
Right. So my understanding was
yes, the server receives a message.
my understanding was these data in SYN things were out of band, could be out of band from the perspective of the application. Is that not true? That is the needed magic, right? So if you don't have that, it doesn't work. You need. I mean, I think David and Andre would agree that like the best case scenario is if we can send keying material in this first packet and have it be ignored if the other guy's not smart. As far as I can tell, no matter what your design, I mean, it's obviously the case that if you waste your first message saying I'd like to do this, like you've just wasted half a round trip for no value. Next slide. So.
Hi, Ecker. I was just going to tell you to move on because you're trying too hard, and where we're already trying very hard to figure out how to do that magic.
Oh, okay.
So, but then I basically had gotten here, and then you moved on. So that's good.
I'll stop selling past the close. You know, TLS obviously is a very general system that has both good and bad features. We're in the process of trimming out a bunch of the stuff that is general, and some of the stuff that was older and is no longer cool. It will still. There's no question that by the time we're done, TLS will still not be as small as a single-purpose protocol, simply because they have to cover too many other cases. That said, the necessary subset for doing this job is not that complicated. It's pretty clear what the subsetting exercise actually is in terms of doing it. I'm not actually concerned I'm not unwarrantably concerned about the complexity issue. Next slide. So look, I mean, I think this is exactly the same slide I showed when I first presented this. I think actually that, you know, these are a pretty obvious set of trade-offs that people, if I have different opinions about what the value of each of these properties is, but I think this reasonably accurately captures the pluses and minuses of this kind of design. It's easy to specify. It's easy to implement if you already have a TLS stack, which most people do, and you get to leverage all the work that's already going in. Bob.
You've got to the bottom of the slide, have you? Have you finished?
No, I'm not done.
Yeah. Go on.
Okay. As I said, it looks like existing TLS over TCP on the wire. While I'm sensitive to Brian's concern about our lack of data, the available data we do have suggests that the extent to which people do stateful inspection, they're willing to tolerate TLS better than most other things. Big disadvantages. You know, you're importing all of TLS, you're importing the history, and some profiling will be needed, and that's necessarily the case. You're not going to get as optimized a system, though part of the optimization here that we're foregoing is the optimization of putting the MAC in the headers rather than the body. You were saying something earlier, and this applies to any TOV structure, whether it's TLS or otherwise, about spanning segment boundaries. This should, unless I'm missing something, one should be able to handle this pretty effectively in both cases, with some attention to the MTU by driving the nominal MTU for the application perspective down a little bit. And don't get me wrong, you're still going to get resegmentation occasionally, but you're not going to. But as long as you're careful, you won't get it very often. So I'm not actually that bent out of shape about this TLV thing. Next slide. I'm done.
Okay. Bob Briscoe. One of the main benefits that Andrea was talking about is the ability to build authentication on top of the encryption.
Yes.
And I think that's one of the key things here. And I'm sure you can do it, but you haven't ever described how. Or,
I'm sorry. That's because it's a standard feature of TLS called channel bindings.
Right. Okay. You might want to write that in the draft.
Oh, sorry. I can write that down. I guess so. This is the dual. This is the dual of the way of all this history. Is many of the things you want have already worked out, and this is one of them.
Right. And Andrea, does that satisfy you?
Sorry. You need a channel binding.
So we have remote people. So if you want to talk, go to the mic. I mean, please talk, but get up.
Yeah. So I don't know the specifics about TLS channel binding, but what I could say for like Tcpcrypt session ID, one of the key features was that it's just like super simple to use, and also it gets rid of a lot of the typical mistakes programmers do. So, for example, there's fresh randomness both from the kernel, from the server and the client provided inside that session ID. So even if the application has a broken source of randomness, just by using the session ID, he's got himself covered. So at a minimum, the channel binding API or whatever it is should be, that kind of dead simple to use, and you don't have to shoot yourself in the foot with it or something.
I agree. This is the same properties that channel binding aims to provide.
And has the triple handshake problem been fixed? Sorry, I just ignorant.
Yeah, there's
so now channel bindings are secure.
I mean, if you implement this, if you implement the right part specification, yes.
Okay, so maybe some people it'll be fixed in some.
I mean, it's in boring SSL now. It'll be in Open SSL soon. It'll be in NSS soon.
So
it's in S channel now.
I'm sorry. This is David Maziers from Stanford. I had one point about TLV, and again, I'm as part of the Tcpinc person, I'm mostly interested in getting feedback. The issue of segmentation and choosing the MTU wisely and so on is that helps on the sender, but I think a lot of complexity arises on the receiver. Let's say you have only a small window left and you receive the first segment of like a 64K thing. Like you start buffering a lot of data and that you haven't yet, do you allocate a lot of space to buffer data so that you can check some MAC? I mean, I don't know, the answer is maybe yes, but there are a lot of these kinds of design decisions that come up, and the thing, while I do think there are advantages to TLV, it forces us to make a lot of design decisions where there's just no decision to be made if you're using a TCP option. It just kind of preserves the semantics of TCP in a very straightforward way. So it's not quite as simple as just fixing the MTU or emulating a smaller MTU.
Sure, I agree with that. I guess what I will say is that this is already something you have to deal with in TLS stacks all the time, and the typical practice is to keep your record size relatively small, so you never have to do too much buffering. The maximum record size is what, 2 to the 14, so even in the best case, it's not that big. In the worst case, it's not that big. But yes, I agree. It's obviously much more straightforward mapping. If you pull my slides back, right? That's why this is in the disadvantages section, because it's obviously a disadvantage of an inline mapping.
Janai Iyengar, I'll just address this point first. I have a comment on that, which is the strength of having these max per segment and being able to do it per segment is exactly its weakness as well. When you hit TSO or when you hit middle boxes that coalesce segments, right? So it's not clear that it's just a strength. TLV is actually a pretty substantial strength in that case. And another point there is that TLV actually allows you to do this entirely in user space, where otherwise you're going to have to muck with the kernel, which is a much harder deployment problem to solve.
Mike.
We'll get you a mic.
Well, the thing is, if you can do it in user space, then you could just use TLS. TLS works today. So Tcpinc is addressing places where TLS is having a hard time getting hold.
So I think that's one thing actually I'm surprised to hear you putting it that way, because I feel like there are two value propositions here, right? And one value proposition is transparent, safe deployment, and the other value proposition is ubiquitous deployment via the kernel, right? And so the value of the out-of-band signaling is that is not that it's in the kernel, it's that it gives you transparent deployment. And so one side can do it, and the other side get it, so you just got opportunistic value, right? It's not clear to me, but from the perspective of actually ubiquitous deployment, putting in user space is in many respects much more convenient because user space updates much faster.
But by the way,
our most popular TCP implementation is in user space, right? It's just not embedded in the application itself, so it's compatible with legacy applications, right?
Wait a second. There's going to be my proper presentation about the framing protocol. So if you have questions about the framing protocol or TLV or something like that, I think we should refer them to after that. So if you have some other questions with the TLS presentation, then continue.
Okay. Well, a quick question on what you call the minimal TLS, and this probably applies to the Tcpinc one as well. So feel free to push me back if you think this is one of those framing questions. It seems to me that there is something that's even lesser. I mean, yes, for ubiquitous deployment and to be able to get into applications that don't have a clue, you'd want to have this TCP handshake, but there are applications that I might build that I don't need to handshake. I don't have a plain text version. I just want to use the TCP crypt as it comes. So if I don't have I don't even need the handshake in TCP if I know that the data that's coming in is crypt or TLS. That is an option that I would recommend that we expose.
Yeah. Sir.
Daniel Giffman at Stanford. I just want to point out that if we decide that that the middle box problems are so great that we really do have to do a TLV sort of transport, then and then if we go ahead and draft something called use TCP crypt, basically using a similar protocol to use use TLS, then we end up with two proposals that have a lot of the similar very, very important features. One is that both can do authentication. Use TLS can do that using its indigenous authentication mechanisms, or it can use, as far as I understand, it can export key material in a way that would be parallel to TCP crypt session ID. And so this could be used in a similar way, and in fact, applications could use it without even knowing whether they were using TLS or TCP crypt as the kind of encryption stream. Second, also, they're both amenable to a future upgrade to MAC'd headers, because I mean the two proposals would be similarly vulnerable to off-path injection attacks, but we can solve that in the future by taking that same session ID, that key material that's extracted from either proposal, and using it to MAC the headers, like the TCP/AO or with the TCP crypts MAC option. And so after those major issues have been addressed, we're left with just a question about which kind of crypto you like better. And we can argue that separately, or we could even deploy both.
Welcome to convergent evolution.
So sorry, just to clarify about the last comment, we're not going to do both. That's the only thing that's very clear.
Bob Briscoe, actually very pertinent to that point. I'm just getting a bit worried that, but in both cases, we're talking about things you could do, but they're not written down. We haven't been able to review them, and we're being asked to make a decision about these things. There's so many things being said that you could do, but in security you can't just go on arm waving. It's going to be really difficult to make a decision about this.
So Bob, so the rationale for this is maybe not. It's not the right path, but that's what we think at this stage is we don't want to progress with two proposals that they end up being really mature, that they have all the features worked out, because it's a lot of effort. It will be very hard. It will be as hard as now to make the decision, right? So what we really want is to pick one, right? Assume that it's very, very an initial version that anything can be changed, right? And work on that and make that one to look like the way we want, right? So
I'm not disagreeing with you. I'm just saying that neither protocol at this meeting has done that, and so I think we need to get to that point. But I don't feel we're at that point where I can make a decision.
Sorry, I don't understand what point.
Where both of them are specified enough that we can make a decision.
That's what I'm saying, that we don't want.
So my understanding is both of these can be made work, and people should have interest in understanding how they can, what kind of modifications the draft needs to be done to be able to support all of these things that we want to. The difference is that we don't also want to, have the authors of the draft authors to, make these modifications, big modifications, and then we see that, okay, yeah, you wasted your week to make these modifications. Actually, and we are going to pick the other drafts. I don't want to have that one happen. I want to, and as I said, yes, the protocol is most likely going to be very similar in both of cases. We are doing the same. We are solving the same problem.
So the details of getting a low latency startup or whatever are really critical and difficult, and you can't just say arm wavingly, we can probably do that. The details of getting key exchange down, in a protocol that maybe it's out of order because it's in the headers versus in the body where it's in order and all the rest of it. They're details that are really important, and I'm just seeing arm waving.
Can I just make one clarification? We're not proposing to change the key exchange and key agreement parts of TCP crypt. We're basically what very close to what they would be. We're mostly proposing that if that's a sentiment of the room, we would change the framing of the application data. So from that point of view, the low latency stuff, we at least have one implementation that works.
Yeah, I'm not just criticizing TCP crypt. I'm criticizing the other option as well. You know, I'm just saying.
So that's sure.
One more thing. You know, we're under charity here. The people who want to get things through here have to do work.
Right, and picking up Bob's last words, like Martin Stiemerling, your responsible area director, just to emphasize what the chair said, like there's no space for two documents progressing in this working group. We need to find out what is the base to start off and to work on one single document. And the initial document does not need to be perfect, but we need to start just to avoid that we like spend effort 2 times in parallel and groups fight each other. There are multiple ways of getting out of this, but I'm not pulling this by now out of my pocket. It's just like I want to listen carefully, just keep this in mind, and it's not like my proposal should be the better one. It's maybe keep in mind everybody, we want to have a solution which works for the people out there.
Steve Kent, BBN. I'm going to disagree with the previous speaker and agree with the previous speaker. If we're going to make a decision, it should be based on a concrete, fully specified proposal. So I disagree with the suggestion that we should pick one now based on how far the specification is and then work to get it to be right. I think each proponent should do the work necessary to give us their best and final proposal for this, and then we can make a decision. I don't think it's appropriate to say that we should make a decision now based on incomplete information, and then having locked into that, we'll beat it into submission.
Just a correction for myself. Just a correction, maybe I said it wrong, but I didn't say that we need to pick one, but we need to find a document where we're working together.
And we find a basis document that we continue working on.
Ted Hardy, as you've noticed, there's a series here, and my place in the series is to disagree with the speaker in front of me and agree with the speaker one in front of him. Just check. So my argument with Dr. Kent and with Bob is fundamentally I want this to deploy, and the faster we have one thing to work on that gets the energy of Professor Mazieres and Reverend Rescorla together, the faster I'm going to get something deployed, and more people are going to get private communication, and that's a good thing. If we have all of the energy in this room focused on one thing, deployment will happen faster. And yes, obviously, if we had a beautifully worked example and one that was complete crap, our job in choosing would be different and easier. But that's not where we are. We've got 2 good proposals. We need to pick one to move forward. And please do not wait for perfection in 2 proposals to get this out. Thank you.
I'm sure I could find some way. No, I guess what I was going to say was that if people do feel like they that they don't want to select between proposals until they're more fully fleshed out, or with the issues, the holes that they perceive in those proposals, it sure would be nice to know what the things they think like to see a full description of for. So like I know like so Bob called my attention to the fact that like I didn't specify how to do like the channel binding, so like I could certainly put that in. But if I had an inventory of all the things people were concerned weren't documented, like that'd make it much easier. I suspect David and Andrew to feel the same way about it, because otherwise you're sort of trying to like, okay, I'm shining it one more crank, right?
The low latency stuff.
Oh, okay. Yeah. I can certainly go into that in more detail. Yes. So I guess all I'm going to say is if you're going to say please don't pick until it's more shined, hopefully in the discussion going forward we'll have some sense of what the gaps will be.
So Stephen Farrell, disagreeing with the previous speaker.
You'd like not to go with this.
No, I would like not to spend. So the other alternative path I don't want to go down is to spend time writing requirements or So. Yeah. So no, I think we should just kill one of these puppies and move on and make the other one better.
When I look at these proposals, without having, I look at them both being very good. There's one question I have for the TLS variant. The one one thing I do like in TCP crypt is that it doesn't require any credentials on the responder. Whereas, as far as I know, a TLS implementation requires, okay, today, in all the deployment I see, if you do not have a properly formed CA certified certificate, you get a bunch of error messages that throw off the user and are not there. So,
sorry. Can people reply speaking on the mic, because at least I don't hear anything.
So basically, yeah, I understand that we can certainly engineer TLS to not require credentials, but we have not deployed that very much.
So I will disagree a little bit. So there are two main options for operating TLS in modes where you don't really have CA certified certificates. One is to do self-signed certificates, which and the other is basically TLS now has a I can't remember what you called it. Hanas would know. What's called an out-of-band key mechanism, which basically means that the keys are just carried raw. And at least the self-signed certificate one is very widely deployed in WebRTC, with basically what WebRTC uses. And so, I mean, it's certainly true that any browser that connects to a server that has a bogus cert company has a complete freak out, but that's not specified in TLS. The TLS just says there better be a cert and you do something with it. So, I mean, don't get me wrong. I'm not suggesting that self-signed certs aren't like a little gross, but it's not like actually a technical issue.
Kulevin, I have a question. Is there an implementation of your version? Is there an implementation already? I mean, if we do a random pick, then that might be an influencing factor.
Yes.
Kind of following up on that point, and also addressing a point that Eric made, that he wants to know, what is it that people want to see fixed, and actually expressing one of my own concerns about moving to TLV for TCP crypt, even though I sense that may be the direction we're going. Once you go to TLV, it's going to change a lot of semantics of things that like everything other than just the payload data in TCP, things like socket buffer size, et cetera. And it would be nice to have like an implementation so we could at least say like, oh, we're doing what that person's doing and that seemed to be okay, or actually no, we're doing something else because of what happened with that. So that's one of the things that that I think would be nice to have more data on.
So if I can go with my presentation, I will hope that will actually answer some of the questions. So if you can, is it related
5 seconds.
to framing or something else?
It's related to the implementation point. Bob Briscoe, just to say that the inner space thing I presented in Hawaii is a framing protocol, and we're in the process of implementing that to put Tcpinc inside, TCP crypt inside it. So, and that isn't implemented yet, but it's.
All right. So if you go to the next slide. So I'm going to talk about a little bit about the framing stuff, because I think this is actually important thing, and I think it's something that we actually want to do in this, because it will allow us to, to get maximum deployability. I mean, if we have a feature, even if it's as well as like we have, it protects everything and does everything nice. If it doesn't work, it's useless. I mean, the worst thing is that if it works so that it starts working, and then suddenly you send some bit in the header that is protected, and somebody in the middle clears it out, and then suddenly your connection just dies immediately, and there is no way to recover it and start over. So that's actually the worst case. So now when we are actually not protecting the TCP header bits, we should to move as much as data stuff in the inside, and we have actually lots of experience, and that's for example HTTPS. Meaning, we have lots of protocols running on over TLS, which are actually using this kind of framing protocol. They don't usually. I haven't heard about HTTP servers to have a window problems or segmentation problems or anything like that, because I mean applications usually don't really care about that. They send data, they receive data, they use just send stuff back and forth. They don't care about how their TCP splits them up. So in that case, I think we are going to be needing some kind of framing protocol, and we are going to be needing in the beginning. We are going to need kernel modifications in every implementation. We are going to want to have the one bit, or one option there in the SYN packet saying we are doing Tcpinc. And I don't know any way to do that without modifying kernel. So we are going to be needing kernel change anything. The rest of the thing, how much we can move to the user land or anything like that. If you are just doing this, I don't know if people know about this. There was this Soxify program. This actually is a program that preloads some of the libraries that will change the socket calls so that it'll add 5 bytes of that telling, oh, I'm going to connect to this server, and that will actually connect to completely other different server, and actually then send it, oh, I'm going to go out through firewall. This is something that actually could be done in Tcpinc also. This one application you could test and implement it completely in application level, and then just put the one library would just send then tell to the kernel, yes, put this flag on, and if it is on, then we are going to be doing this our framing protocol and crypto on there. So it allows fast implementation and prototyping.
Paul Vargas, Red Hat. Please don't do anything with LD preloading or library loading. Like that's something attackers use, and we're trying to make it harder and harder. Don't make something that uses this, please. Thanks.
I was saying you can do. I was saying actually, and actually, as people are saying, yes, in the final program or implementation, we want to have it in kernel. But while we are testing it, actually, it makes things much easier, and that will allow us to get implementation, this kind of how well it works in different environments if we can get actually running very quickly and easily.
So just to make a point that I think it satisfied both of you, the TCP-crypt user level implementation is not an LD preload thing. It's just a separate daemon that runs, and it uses divert sockets. And so I totally agree about the user mode implementation. And initially we thought, kernel, it's faster, whatever. And like from the companies we've been talking to, people are much more willing to deploy this if they don't have to change the kernel. But yeah, let's not have LD preload as our reference implementation.
Yeah, I was just pointing out people talking about moving stuff in between user and kernel mode. So we need the kernel module anyway to set the flag, the one TCP option in the SYN. Rest of that can be happening very. No, but if you have a TCP SYN option, if you have an option in TCP, I don't know if you can actually add random.
We have an existence proof that TCP crypt runs entirely in user mode, does not change the kernel, because if you're writing a daemon that like is rewriting your packets, it just adds the TCP crypt option. You don't need to change the kernel for that.
Okay, yes. So I wasn't aware of that. When I was looking at TCP BSD sockets interface, I couldn't see anything that actually could allow me to add random TCP options in.
Quick question clarification question on this. Jana Iyengar, is there an equivalent interface for Mac OS and for Windows?
It works on all right. Yeah. But it's implementation stuff. I don't think we need to talk about it here.
We have implementations working on all the platforms.
So that's fine. Okay, go to the next slide. So if you're going to add this kind of TLV framing protocol there, so we need to have some kind of type length and data there, and with the data we want to have it encrypted and macked. One of the features actually is that because currently if you see that most of the what the security community is going is we are going to be using authenticated encryption modes. We are going to use these AED modes where we have to encryption and authenticate at the same time, ASGCM and ASGCM and so on. If we put the MAC in the outer header, we can't actually very easily use those because there is actually, yes, it returns the data and the MAC, but the interfaces are so that you actually don't know where it actually switched from the data to MAC and so on. You get the binary blob that you're supposed to be sending, and when you receive it, you get the binary blob, and you give it as a one object to this decrypt operation, and you get, oh, it's fine, and here's the data. SSH has this problem because it actually encrypted, this length field, which caused the problem that it couldn't actually use those very well because it first needs to decrypt the first bucket, and you couldn't decrypt it because the AED modes didn't allow you to do that, so it was actually very hard to implement. So that's why actually I think one of the things that we benefit for here is that we can actually use these modern modes. And what kind of format we actually have there depends quite a lot. In TLS it would be TLS record layer, which actually is the same kind of thing. In TCP crypt it would be something else. And there is some things that we have to decide. We for example, are we going to encrypt a type? You were saying, oh, we encrypt it. And in some cases, actually, it might be beneficial not to encrypt it, mostly because we can actually, it leaks out information, but it also can be something that can be, we can leak out information on purpose. For example, for example, it's the shutdown messages are one of the messages there. Somebody who is actually the middle box who actually knows about Tcpinc can actually recognize, oh, this is actually now it's shutting down, and it's actually beneficial for me to know that it's shutting down, so I can actually start tearing down the information. So this is one of the design choices we have to do, and I have no I don't know which one is better, to be encrypted or not. Of course, when we are actually doing the the initial stuff, meaning this key management, then we don't have keys yet, so the packets are going to be plain text anyway. So there is one of these things that we have to think about. And if you go to the next slide. So we need to have some kind of types there that actually allows us to do key management. Rekeying is one of the things that actually would be nice to have. Most likely in version 0.1 we don't need that. We can actually, one of the good things about this kind of all of these things that we add, if we add a new TLV, we can actually add new features much easier in the later. We just, next type, we have a type 7 that is rekey, and the other one can say that, okay, I don't do rekey. If we do the protocol correctly, we don't have to, we can have this kind of, we can add features later. And so then we need to have some method to encapsulate the whole, the real data that is going to application layer data. And then we need to be, we can try to make it so if you actually do it in the kernel-based implementation, you can try to make as well as possible to keep the, the TCP segments and the, the record layer segments to be same, just for performance reasons and so on. If you implement it in the user mode, you don't have no idea how the TCP is actually going to be segmenting it, so you just have to do some kind of best effort guessing, say, okay, I used, 500 byte records just to make sure that, okay, I don't have this problem and I sent 65 kilobyte record, and then you have to receive it completely before you can actually start decrypting and checking it. So you want to have some kind of, this is implementation issues that you have to be thinking about. And but as I said, with this, even if we try to keep the segments and the records at the same, going at the same time in sync, there might be a middle box is actually messing it up anyway. So we can't rely on that. We have to be able to, reconstruct the record stuff from the, from what's inside the stuff. Go to the next slide. Then we have some issues there that is something that, okay, in some cases we might want to replicate some of the TCP features. I'm not talking about now bits in the outer header or anything like that. I'm talking about features. Like Eric was talking about this closing down the message. We might have this kind of finished message inside our stuff, and that would actually allow us to modify a little bit of TCP, whether, for example, TCP cares about the fin bits or not. It might actually be ignoring the fin bits unless it sees this, this. Or it might be just doing the normal. In the first version, we most likely don't want to do any of these. In the future version, we might want to do either. There's other things is, in most of the, things we have in outer header, they are not interesting for the passive, monitoring, operational monitoring stuff. It doesn't really matter if, somebody can see that, yes, I'm shutting down. It's actually very obvious that you are shutting down. We don't need to. If, of course, it gives you the active protection, but that's not our main goal here. But there is some more problematic stuff like an urgent pointer, which is what I heard is supposed to be obsoleted anyway, but it's still going to be used in some application, which means that we have to somehow make it work, for example, for telnet to work. So we might need to be able to do something, we might do it so that we just say that, okay, the urgent pointer is, we put the urgent data as a separate record in the beginning, and we just adjust the pointer to be length to include the overhead. Or we might just make say that we don't care about the urgent data bits in the header, but we allocate new type for it and say that all of this, if the type is 6 instead of 5, then it's going to be urgent data, and if it's 5, it's normal data. So, but this is something that is, again, something that we need to be solving. For TLS, we have to have some kind of, method for that also. So it's actually not something that needs to be solved in both these methods. So I think that was the last slide, if I remember correctly. Yes.
Okay, Keith Moore, yes, I agree. You have to, whichever solution you pick, you really need to have the same effect of urgent data. You need to be able to support half closes. The applications that use these are rare, but they are important to some people. And I don't, particularly because this thing is something that's going to get sort of imposed on applications where they like it, whether they like it or not. I think basically you can't cause random breakage. And I've tried to run some of these application protocols over other kinds of transport that don't support these features, and it's actually quite hairy to work around.
Yeah, and actually one of the things is for example, urgent pointer, if we don't implement it properly, we don't notice it in the beginning, we notice in the middle, after 4 hours of running the TCP session, you press Control-C or do something that actually causes the urgent data go, and then you have, this random break is happening. And in the worst case, it would be authenticated, urgent pointer that is cleared by the middle box, and suddenly, all the packets go dev null because they are failing the, authentication.
Okay. So Richard Scheffenegger, we've just had a discussion about the urgent pointer. The urgent pointer has been deprecated for a long time, so you don't need to worry about it.
I think it's obsoleted for new applications.
People are still using applications that use these features, yes. So sorry, you do have to worry about them. You're imposing this, you're changing the behavior of the network. Yes, you need to worry about it.
I have some data on this. Do you mind? Yeah, because I looked through, I use Arch Linux, which is a relatively recent distribution. I looked through the source code, and it's like there are two applications that, like FTP and Telnet, both of which are, still used, that do have uses of urgent data in the source code.
That's correct, but the implementation of the urgent pointer in different operating systems is broken and not compatible. Therefore, nobody really is using the.
Okay,
That's true, but they're not.
It's not something that we need to decide here, and actually, I don't think it's actually beneficial to the.
I think what Richard's saying is, given it's broken now, breaking it a bit more isn't going to worry.
David Borman, just one comment. The brokenness that they're talking about with urgent pointer is the presentation to the application. It has nothing to do with the on the wire. So in terms of whether or not the applications are broken, on the wire it has not changed, and there is no interoperability problem on the wire with the urgent pointer.
Okay. I didn't see any discussion of MTU changes.
So MTU changes, I don't really, applications usually don't know the MTU.
I get that, but I mean it's part of the thing that change underneath and can have interesting effects. And especially if you have a Mac on the previous MTU, and then what happens?
So if you actually keep the framing protocol and the segments in sync, you actually have about the same overhead for the exactly same overhead for each frame or each segment, because you're going to have type, length, and the MAC. So you have certain amount of, and it's fixed, which means that if you have a path MTU calculation, actually path MTU calculation actually works before we actually see the data. So actually we need to just when we are, the TCP probably wants to, if you're doing the kernel, you want to make sure that it actually doesn't use the full MTU, but it knows that there's this overhead and calculates it.
Well, the specific case is that you add an MTU of 2 kilobytes,
Yeah.
And you are sending a packet of 2 kilobytes with a MAC, and then something changed and your MTU is 1 kilobyte. And you have lost that packet. How do you repeat it? It's basically a test case I'd like to see what happens.
It's a TCP frame. You just retransmit it. You fragment it. You send it in smaller pieces.
Okay, I suppose that if we have a strictly an inner TCP outer security work, yes, it works. If we try to do MAC per frame, then it does not work.
Yes, that's the TCP crypt has had quite a lot of text in there. Actually, if you need to retransmit any, or if you have to, you know, I think you had said there's this was like calculating the things different and, you know, giving the offsets. And if I remember correctly, it's sometime when I've read it, but.
Yeah, your optimizations for. So in an attempt to be David Maziers from Stanford. That was mostly, I think what you're referring to is an attempt to be friendly to middle boxes that tend to modulate sequence numbers. So, so it's just that. And then the other thing that we did was because some middle boxes rewrite the timestamp option, we had to have our own kind of secure timestamp. It was relatively straightforward. It didn't involve kind of duplicating TCP acknowledgements or anything like that.
So it was so that if you retransmit it, you just MAC'd it again and you added a new header in that.
Yeah, we optimized the MAC so that it was like you could update the ACK number and retransmit without having to like flush your cache or anything.
Tara, a question on your presentation. As you know, I presented the framing protocol at the last IETF, and it's fully spec'd. And were you describing something that you believe is the same as what I did, or because it seemed to all be, you know, you had a list of requirements, or
I think it's mostly the same. I think there are several people who have been expressed that okay, this kind of thing is needed regardless of the solution we are going to be selecting, and there was some discussion in last week in Tcpinc, or actually a week before that, in Tcpinc list that was bringing this up again, and I was saying, okay, it might be useful to have some kind of presentation that is not tied to any of these, you know, proposals in any way. It's just, you know, trying to explain a bit more about the, you know, record layer or generic issues in that.
Yeah. So, excuse me. Yeah, and I'm trying to design a generic framing protocol for multiple purposes, not just Tcpinc in TCP, and I believe it meets the requirements you said there. I guess what I need to do, and what I am doing at the moment, is breaking out like the handshaking part of it, because there are various proposals on how to do that, and so just having the framing protocol on its own. But otherwise, I think, you know, it's a TLV protocol, and I've also sent an email to the list saying exactly how you would do TCP crypt in it. Admittedly, I haven't said how you do the TLS option, but partly because I thought that was fairly obvious, but can do that as well. In the interest of trying to specify these things.
Janai, what is the conversation that we're having right now?
What?
Which of these conversations are we having right now? Are you doing the framing protocol or the discussion about the orientation?
Protocol, the last one. Yeah, I was coming here trying to announce, but because there was a line there, I wasn't sure which one of those was still related my own. But I was thinking about we should move to the discussion about the protocol, you know, adaptation. So actually, in this part.
Well, thank you. I think framing is an important consideration. I think you'll keep hearing comments on that. I'm going to comment about that as well. I think it's really important to consider trying not to touch the TCP headers if we can avoid it. This is not just because of those random middle boxes once in a while which are there. We had this conversation in TCP-M earlier this week about how EDO, which is an options extension that does things on TCP options, interacts poorly with TSO. This is hardware stuff, right? I mean, so there is an important question here of deployability in the network. This is not just about whether you can get the code in there and get the packets out. This is about whether servers will actually adopt this and use this on the server side. So I think it is kind of important to see how this fits in the ecosystem that we currently have. And to that extent, it's useful to think about TLV as a way to simply sit on top of a substrate, which is TCP, and just do things on top of it without challenging the substrate and therefore having to deal with the negative consequences of challenging that substrate. I think InnerSpace does this in a very general way, and I think there's a far simpler version of InnerSpace that's perhaps adequate for this. Even TLV will do, because that's really quite adequate. And just one small thought, that the urgent pointer conversation brought to my mind. We could use 13 bits in there for sending the MAC.
Hi, my name's Tim Shepard. I think if I've understood everything, and I probably am not quite understanding everything, but I think if I've understood everything, we have three choices, three things to choose from, and the goal here is to choose one, if I've understood correctly. So,
Three?
what?
What are the three? Sorry.
Yeah, and I should probably explain that. So, one is Tcpcrypt as is already implemented, and that some people are running, and there's websites you can test it on and everything. With the framing that it currently uses, which is just a TCP packet. And that's problematic in some ways that some people have pointed out, and there's been lots of discussion about that. The second option is to do TCPcrypt, but understanding that we're going to have to fix the framing to do a TLV-like thing. I think that's the second option. And the third option is to do what Ecker's proposing, which is the simple option to say, hey, let's do TLS. We already know how to do that. And the only thing that needs to be that's already deployed running code. The only thing that's not deployed running code is the fact that you don't know whether the other end can do this or not, and you risk disrupting, blocking, making it not work, the application protocol when it gets the TLS negotiation at the beginning, if I think I've understood it right. So it seems to me that, and now I will express my opinion, is that the only, of those three choices, the only one that I think should not happen is the first choice. Because, and if it's sort of sad if the Tcpcrypt effort had originally done the TLV thing inside, and all that running code that was out there was in fact doing the TLV thing, then I think you'd have a very strong case. Look, we have the running code and it's close enough to the right thing, we should just go with it and get it deployed quickly. But I think the framing issue is important enough that we ought to fix it. And then that leaves me the question is, I wonder, of the two choices remaining, choice 2 and choice 3, which of those two choices we are closer to having running code. And I don't have enough experience taking TLS libraries and trying to hook them up with code. I've essentially never done that. I think I once looked at a TLS library and downloaded it and started reading the documentation, but I did not get to the point of writing code. But I think, I fully expect, my imagination is that that actually does do enough framing so that we don't actually have to invent a framing protocol to just do the TLS thing. And maybe Ecker can confirm or nod his head or something.
I can actually answer a bit of that. I think in both of the cases, we need to have a new code. I mean, in Tcpcrypt, yes, we need to add a TLV stuff there, if we go that one. In TLS, we need to add some of these corner cases. Its record layer is good enough, but it doesn't support, urgent data, it doesn't support half close and that kind of thing. So it's actually still missing some corner cases. And also, as I say, to be useful really, we have to profile it anyway. We have to, say that, okay, use these features, don't use these features, use out-of-band certificate, certificates with these kind of things and so on. So in both cases, I think we need to have new code. And also, I mean... And
then those corner cases would be the same for choice 2 and choice 3, I believe.
Yes, they're actually going to be the same also with Tcpcrypt, because then with Tcpcrypt we can't anymore use the header stuff. It's going to have the same kind of issues in there. It's going to be a record layer is going to be different. The TLV is going to be different.
So that's going to be the important work. Thank you. You've helped me understand things, but I hope my framing of the three choices is helpful.
Keith Moore. When I look at this and I say, what do I think is important as an application writer, application developer, and what I think is going to affect applications, there's a certain set of things I find myself caring about. One, of course, I mentioned earlier, I don't want to break things, even obscure things like half open and urgent. And one is I really don't want to discourage. I feel like there's a lot of investment and a lot of mind share in the application community around TLS. and around the API, around the set of cipher suites and that kind of thing. So whichever approach is chosen, I feel like it needs to be compatible with that. So if you go TCP-crypt, then there needs to be a TLS layer that works and makes sense on top of that. And I understand that there has been at least such a thing. I haven't kept track of it recently, but there was such a thing at least for an early implementation. But part of that investment is actually some understanding within the application developer community about qualities of cipher suites and how these things are evolving over time and that kind of thing. And I really don't want to lose that. I feel like it's important. A related issue is, and I brought this up in Toronto and I kind of got shouted down for it, but overhead really matters. So if you end up running multiple layers of encryption, I'm not saying things will break, but server load matters, overhead matters. Okay, so I think it's important when the application is unaware that this lower layer has been added to it, reasonable things should still happen. And part of that being reasonable means it shouldn't be too inefficient. I'm wondering, I haven't followed the multipath TCP stuff recently, but I'm wondering if anyone has looked to see how well these things mesh, because I feel last I knew that seemed like a fairly promising approach to a number of problems that modern hosts and applications face. So, you know, that's kind of out of left field, but I feel like there's going to have to be discussion on how to get these options right and how to get the framing right and all that anyway, and I feel like that's probably part of that discussion no matter which proposal you go with.
So just to answer your question, in terms of integration multipath TCP, there are already drafts about how to integrate TCP-crypt with multipath TCP and how to integrate SSL with multipath TCP.
Okay, so at least people are looking at it. That's awesome. Let's see, just make sure I haven't left anything out. And I guess the other thing is the ability to evolve this stack as we learn more about vulnerabilities and this sort of thing is very important. And so I feel like TCP is a little stronger than that area. But ultimately, I really don't feel like we should be deciding between one approach or another. I feel like we need to sort of understand the desirable characteristics from the application's points of view and go forward with one proposal collaborating on bringing expertise in. But I do feel like that TLS API and the cipher suites and that investment is very important.
Stephen, just on the running code kind of issue, I think there's something I'm not 100% clear on, and I think the answer is behind me. I think we should be quite clear on what version of TLS we're talking about here. You know, is it only TLS 1.3, or is it, you know, is the proposal to use TLS 1.2 and profile that? Because I think those are quite different exercises.
I think we are talking about TLS, you know, Tcpinc version.
Well, no, but starting from where? I mean, if you're starting from
I don't know. It depends.
So I think that needs clarifying, and it has a big impact on the running code argument.
Sure. So we're closing the line because we're running out of time.
Sure. So let's maybe in some attempt to answer multiple questions in order. Let's see. Stephen's question first. So no, I was not. I was assuming. What I had in my head was TLS 1.2 or 1.3, but profiled down to the cipher suites that we've already decided for 1.3. That is, we've already built an understanding of what the approved modes are, and that's a short list to make. And so I was thinking either 1.2 or 1.3, but with that same reduction in force, i.e. all PFS, AEAD only, that kind of stuff. That's a short list. As far as sort of the software integration question, I think Tim was sort of asking about, you know, either of these systems, right? The point where basically you just have a signal in the header and then everything else is being done essentially in line, right? Then there's sort of a split, but you say, look, what I need is like, you know, a gizmo to shove stuff in the header, and then a gizmo in some way of, you know, writing the data out onto the wire, right? And so in a sort of so as I said earlier to David, you know, I view a lot of the value here as just the out-of-band signal, even if you did this entirely in the application layer otherwise. And so obviously I'm running code for that right away, right? Basically it's like whatever running code is, you need to make the option, and then you just run TLS in the application. If you want to do something that covers every application in the system without modifying the applications, then you would need the plumbing to go in and out of the TCP stack as well. Like I say, I'm sort of surprised. Again, I'm sort of a little surprised to see so much focus on uncovering every application in the system, because my experience has been that the kernel upgrades incredibly slowly and the applications upgrade incredibly slowly. And frankly, if we just figured out how to signal that we wanted to do TLS in the applications out of band years ago, many more applications would just do TLS opportunistically than do now.
Governor, there was some comments here about how TLS has been deployed over the internet, going through all sorts of middle boxes. We know about TLS going over TCP port 443, where everyone expects the TLS to be. If we run TLS over, say, TCP port 80, we're going to run into trouble, because I'm not talking about firewalls. Firewalls know how to strip the stuff they don't like. But think of a transparent proxy, a transparent caching proxy. It sees the TCP port 80, it expects to be able to do caching. Suddenly it gets TLS client hello. That's going to break. Well, as long, probably so, yeah. Well, if it's a caching proxy, it might be an endpoint as far as TCP is concerned. So yeah, so it could be, so it could break it there.
If it's endpoint,
it's probably going to terminate the TCP and then either support or not support TCP crypt.
Yeah, but I mean I think that's the same thing with TLS. If it supports Tcpinc, then I mean it doesn't run the TCP crypt on the port 80 unless both ends support TCP crypt. So
Yes.
the only problem is actually if you have this kind of transparent proxy that is not part of the TCP.
Yeah.
It doesn't terminate the TCP connections.
Yeah.
And
So we have more trouble with things that don't terminate
and
the
if we
TCP.
kill them, good thing.
Ted Hardy speaking. Just to answer your question, you've used the term somewhat inexactly, and let me help. When we talk about HTTP proxies, there are two classes of proxy we discuss, and when you are a designated proxy, then Tcpinc or TLS will work fine because you are a named party to the thing. But if you are being man-in-the-middled, which is what a transparent proxy does, it must do one of two things. It must do the full man-in-the-middle of terminating the TCP, standing up as a back-to-back user agent, and pretending to be the other side, in which case, in either of these cases, it will function exactly as it's functioning now because it stands up a man-in-the-middle.
We have seen some that allow the TCP connection to start normally and then start injecting things when they want to. Like injecting I've seen stuff like that. It's ugly, but they do it.
I feel your pain. I'm sorry. But the common case for this is going to be that if you are a transparent proxy acting as a back-to-back user agent, you will terminate these connections, perform whatever evil deeds you care to, and then move on. This is why, and it's a very important point here, even if you're doing TLS in this mode, you don't want to turn off TLS in the application mode as well.
All right, Bob Briscoe. The remaining thing, I can't see much between the two that Tim said, and I agree that the first of Tim's three I don't like. In other words, TCP crypt without a framing protocol. Yeah. But the remaining thing I'm unclear about, although I'm getting clearer, is latency. I think it's absolutely important that if we're going to expect people to have this turned on underneath their applications, that it doesn't add latency. And if we add any latency, I suspect most people won't want it, because they will think performance is more important than privacy. Privacy is just an optional thing as far as most people are concerned. Performance is not. And so I've worked out how you can do TCP crypt with TFO in 0 rounds. I believe I can do TLS with 0 rounds before TLS starts, but I don't know whether TLS 1.3 can do, has to add any more, because I don't think we're yet at the point where TLS 1.3 knows whether it can do 0 round. Yeah. So I would certainly not want to put TLS 1.2 in here. I would want to put TLS 1.3 with hope in here. So as far as I know, the certainty is that TCP crypt won't add any latency but it's not that certain. It's still hope, because I proposed certain ways to reorganize TCP crypt, but I haven't had any feedback on it from the authors, so I don't know whether it would be secure. Or the list, actually.
David Maziers. I think part of the choice of which draft you prefer depends on kind of what you see as the vision for Tcpinc. And I think the TCP crypt vision is we basically wanted to guarantee as much as possible that once a TCP connection is established, if you weren't man in the middle, and as long as the attacker can't drop an overwhelming portion of your packets, that basically the behavior is as close to TCP as possible over a secure network, meaning like the attacker can't eavesdrop, if he does off-path packet injection, you just drop the packets and so on. And that's and we wanted to guarantee this for kind of all applications running on the system, because a lot of applications already can use TLS, but there's a lot of kind of stubborn legacy stuff out there, and linking against TLS library is a bit more complicated. People just write simple little applications. So if that's your view of what TCPinc should be, then ultimately its place is in the kernel, even if that's not the first place to get it deployed. And so you want something that's going to be like relatively small, like as the least offensive possible to kernel developers in terms of the amount of code they have to swallow, and so on. I think that a lot of the motivation behind TCP use TLS is if you want to change your application to use TLS, but you're frustrated because you forgot to add space for a start TLS command or something, then you just want that extra bit, right? So if what you're looking for is something to allow application developers to add TLS support in a backwards compatible way, then what you want is something more like TCP use TLS. But you're targeting places where people are willing to change the application, and it's probably not going to get the same ubiquitous deployment as something that ultimately ends up inside the kernel. Because you hear this even when people talk about the implementation, and, oh, just do it as a library, right? And oh, don't worry about some of the lower level TCP things like buffer space. Like nobody's ever worried about that over TLS. Well, that's because the applications are linked to use an SSL library. They're not just using raw TCP and expecting it to behave like TCP. So I guess that's kind of where I see the decision now.
Christian Huitema, to make a point that's kind of a corollary to the previous speaker. The one thing I do understand about TCP crypt is the socket API. I understand how we can start it in TCP crypt mode with some option. I understand how we can get the session ID for an API and then perform whatever. I do not understand very well how I would put the TLS under the socket API. Well, no.
Actually, our charter says that it's supposed to be working with unmodified implementations, so with applications, which means that we are going to be using the application level, we are going to be using exactly the same APIs for both of them. And I see no problem by kernel space implementation of TLS using TCP-Inc using TLS wouldn't work with exactly the same API that works with current socket API.
Well, specifically, if we have to expose the fine points of certificate validation to the socket through the socket API, I don't know how to do that.
There's no certificate validation in TLS if we're talking about this kind of modes. We are talking about either, let's say we are using out-of-band raw public keys. When we have just public key, we have a public key that is only for that device, and it's never actually signed. We have closed the lines already. So we have yeah. Yeah. Okay, perhaps I should allow it. Yeah. So I think.
Well, yeah, I can believe you, but if the only spec I have is it's just TLS and we have started it, then I cannot get that from it's just TLS description. I would like to have a bit more there.
Okay. So let's ask the working group a few questions. So let's start with hopefully a simple one. Okay, so I'm going to ask 3 questions, or 4 questions if you want. So first, whether people think we need a framing protocol, right? Whether whatever solution we end up with needs to have some more TLV format in order to carry the MAC in the data, right? And that will be yes or no. Right, so these are two questions, or one question, I don't know how you want to put it, right? And then I'm going to ask whether people feel that either of the drafts is a good starting point for building a solution, right? So these are the questions that I'm going to ask Hams for. So I hope I will. Sorry. I mean, I will ask support for one draft. I'm going to ask support for the other draft. Okay.
Are we ready to make a decision followed by?
No.
Just to clarify on the drafts. So there's. I mean, I just want to clarify. I don't. You could either say, do you support this one or that one, expecting people to hum once?
Yes.
Or you could also say, do you think this one is a good starting point? In which case, humming twice could also be possible, right? So which way are you asking the question?
Well, you really need to do this.
If we actually want to get some result out, I think it would be easier to actually say that, okay, who would object very much if we actually pick this one as
No. We're going to ask whether, I mean, one draft or the other one. If people want to hum in both of them, please go ahead. If you can do a continuous humming during the whole session, that's fine. I mean.
No, but really, so you would prefer that people will hum for one draft and not for the other one. Is that true?
I would expect that people humming for both drafts or none of them is because they feel that they're not ready to make a decision.
Okay.
Right? So in that case, basically it means that we are not, if everybody do that, basically means we cannot make a decision.
Ted Hardy speaking, veteran of many painful hums.
Yeah, go ahead. So just the thing. I mean, we have 2 minutes left.
Okay.
Okay. Okay. So we're good. The line is open. Yes.
I warn you, there's somebody behind me with a bodhran, so they're going to keep that hum up for a very long time. Let me suggest something. Let me suggest you start with your first question. One, do you think whatever solution is picked will eventually need a framing protocol? That's fine. Do yes or no to that. Any of these can go any of these directions, so you're cool there. Then I suggest you actually start the other direction. How many people in the room are okay with either being the starting point, given that change control will belong to the working group? That tells you how many people in the working group really are fine with it being any of these because they know they're going to be take any of them forward. Then ask your discriminatory question. Is it better to start from X or better to start from Y? Because ultimately, if 90% of the room says it's okay to start with either one of these, I don't care ultimately that you can discriminate between 45% wanting one and 46% wanting the other and the other people sitting quietly. So please, in the interest of getting this out and done and deployed, start first by seeing if we can actually go with any one of these and then go from there.
Mia Kulevind. So I believe we have this discussion because a lot of people sit here and say, both are good, I can't decide now. And like for me, this is the truth, because I would like to see one other version of the TLS to get a little more detail, maybe also in first implementation of it, and then I would be able to decide. And so maybe that's the first question. Who thinks we can decide right now, and who thinks we can't do a decision right now?
Actually, as I said earlier, if you think you cannot decide, just hum for both, and we will not reach consensus. Sorry?
You will not notice the difference. So if everybody hums for
No. The thing is, if we cannot decide, we will figure out a way to decide.
if everybody hums for we cannot decide and nobody hums for we can decide, we don't need any further questions.
Yeah.
So one point is about there was a time at the mailing list where people could already think about it.
But actually,
right?
Yeah.
And
Actually, I think
it would be good that we get some indication. We anyway need to confirm on the list afterwards.
Yeah, but actually I think we should get with the first hum first, because I don't think that there is that much disagreement that is that okay or not, and it's actually mostly covers with TCP crypt, because I think TLS already has some kind of record layer. So would we like to have a record layer in also in TLS crypt, and if that hum is yes, it actually might affect people's opinion on the second hum or might not. So that's why I was thinking about it, and I hope we can actually at least get some feedback on that.
Bob Briscoe, I just want to suggest that rather than having hums mixed in with other hums, depending on whether people are going to hum for the other one and all the rest of it, you can do that if you want, but I would really like to hear a hum from those people who can't decide between them separately, just so for information, just so we know how many people are confused.
Yeah. Okay. Good.
Keith Moore. I actually think that the record layer kind of is not important to know at this point, because whichever proposal you start with, the working group is going to be tasked with making it work, and if that means setting a record layer, then that's what it'll have to do. And I feel like that's sort of a very peripheral issue to the central one.
The reason I was going to ask that one was because there are several people in mailing list saying that they're strongly object to starting with TCP crypt unless it starts to have a record layer, which is I was wanting to see if there is actually more people here or less people here to that, because it might affect us,
David Mazieres. So I think that maybe this is to save us a hum. I think that the TCP crypt author, I just talked to Andre, and I think that given what's been discussed today, and especially the fact that we can't protect the header, which that decision was taken very recently, too recently for us to submit another draft. We think that we will probably, we'll plan to modify TCP crypt to use some kind of TLV thing. So maybe we don't need a hum on that.
Hi, Brian Trammell. The fact that we've had more than the amount of time it will take to talk about the hum, or to do the hum than it was to talk about the hum, I think indicates that this is too early. But
no.
Hold on.
No.
Hold on. Before you get up, can I
finish my statement?
Can I finish my statement, please? Yeah. I think it's too early. I think the urgency of getting something out the door and deployed means it doesn't matter that it's too early. So I think. No. I mean, I would like to see some implementation of the TLS over. I'd like to see at least a little bit of implementation experience with the TLS over. The TLS is Tcpinc, and that's just not ready yet. I mean, that would be a nice starting point, but we can't get there, and we have to decide without it. So I think just take the hum. Absolutely, yes, it's absolutely too early, but it doesn't matter. So I'm agreeing with Marcelo.
So Martin Stiemerling, you're responsible AD. I think if we're at that stage that we say we go back to the lab and make implementations first, that's probably fine, but then we just close the work group by now.
Yes.
So, yeah. Well, there's not a pressure, but the working group wants to go forward. And the thing is, you're not agreeing on the final solution right now. You agree on a starting point and a working group item, and where the working group has to change control to see where you go, and also to support by implementations and so. The thing is that if we have a working group which is not doing any work, we don't need the working group right now. We can start later on.
Isn't the problem that there are too many people doing too much work in this working group? That's why we have two proposals that are both good?
No.
Ted Hardy.
Yes.
Ted Hardy speaking. As an informal motion from the floor, I beg you to call the question.
Okay. So let's start with the framing protocol. Okay, so take this seriously. Okay, so who think we should, I mean, whatever solution we end up with should use a framing protocol, TLV type? Please hum now. Who think we should not have this and we do something else? Hum now. Sorry? Okay.
No, all proposals have a framing protocol.
What do you mean they have a framing protocol?
Basically, today is Tuesday one. We're just getting our feet warmed. Don't worry.
So are we going to have a framing protocol inside TCP or use TCP for the framing protocol? There's always a framing protocol.
We have been talking about this framing
Right,
protocol
I understand.
inside TCP.
I understand that's what I've been talking the whole session, so I would guess that people understood that far, but maybe not. Okay, so next question is, how many people feel that we are ready to take a decision and pick one proposal, and how many people don't think we are there? Okay, so people who think to pick a draft as a starting point to do the work. Okay, so people who think we're ready to make a decision, please hum now. Okay, people who think we are not ready to make a decision and pick one draft, please hum now. Okay, I think we are ready to make a decision. And now, I don't know. Give me 1 second. Give me 1 second.
I think just ask for that has a starting point.
Do you want to make a text question about whether there's any? Okay, let's ask Ted's question. Who think either of these two proposals is a good starting point? For those who think either of the two proposals is a good starting point for the work, please hum now. No. Who thinks that none of the proposal is a good starting point? So, okay, sorry.
Maybe none too.
Okay. Whoever thinks that at most one of the proposals is the right starting point, please hum now.
I think it was a bit more in the first one, I think.
I'm not sure what have we earned at this point.
But let's ask for
Okay, so let's ask for the proposals. Okay, so who thinks that we should adopt the TCP draft as a starting point for the protocol work in the document? Please hum now. Okay. Who think that we should adopt the TLS proposal as a starting point for the protocol? Please hum now. Okay, have some coffee.
So if I would summarize there, what was my understanding? Yes, we want to have a framing protocol. We think that we are ready to pick now. There were bit slight more people who say that yes, either one is okay. I think that was or either one is okay. And the last one was almost even, if it would be, I would say, a bit more in TLS, but that's depends on. But if either one is okay, I think we just need a coin and flip it.
So, Aaron Falk, so I just want to point out that you may think things may have sounded different where you are than they were here, because given the choice of are you ready to make a decision now versus wait, that sounded much closer to me than which of the two drafts people wanted to do. From where I was sitting, it was much clearly stronger in favor of the TLS-based solution. but it was also much closer. There were many. It was much closer that people didn't feel they were ready to make a decision. So.
Can I, Bob Briscoe? Can I just ask, before everyone just goes off, what are we going to do to resolve this? It's got to go to the mailing list, I guess.
No, probably not. So what? So we're
well, okay. Yeah.
So
I mean,
I'm going.
definitely, both authors have got to give more details.
So
yeah,
I'm going to talk to the authors.
Yeah.
And eventually our AD, because obviously, as you may guess, we don't agree neither. Right? So our AD will actually make a call, okay, and decide something.
Yeah, again, me. So I have some closing words. If you'd like to hear them, you can stay. If you don't, just walk off. That's completely fine. So it's as expected, we couldn't come to an agreement to select either one, which reflects what we have seen on the mailing list. So the thing is, we will now go back with the chairs and talk about how to resolve the situation. We have an experimental RFC with various ways of this situation. The worst one we can reach is taking the coin and flipping a coin. And the best way might be we talk with the groups, and we're going to start a design team saying, sit together and get something worked out together. If this is not going to work, because this happens from time to time, then we go back to the alternative procedures to say, we're going to double check if we've done everything right, we flip a coin, or we decide we close the working group. Yeah, so my attempt would be that we work quite fast, meaning we don't hang around for months so that everybody is in limbo, but that we try to get some decision quite soon and to see how we progress.
Bob Briscoe, can I suggest another alternative? That both authors are asked to work on their drafts so we get progress, and the one who gets there first wins.
Nobody forbids that. They can work on their stuff.
Yeah.
So. Right.
The important thing was the framing.
And then we make it.
What? The important thing of my two choices was the option of not accepting. That's very good news. That's very good news. I mean, the night, what I was afraid would happen was that they would go forward and say, doing as many protocols. Would be too hard. We don't want to change all the code. But.
No, Dan. I think those
I